Alright, so this is going to be our first sort of mini project video. So in this lesson, we're going to use everything that we've learned so far, and we're going to create a simple rainfall system. And in doing that, we'll also look at one new node, which is called the pop interact node. So this is the final effect that we want. We just want a simple rainfall, but what we also want is we want these little sort of streams forming. Like when it hits the rock, you get these little streams to form. That's essentially what we want. Okay, so to get started, I have this basic scene here, and I'm just going to paste the, this basic geometry that I have, and I'll just explain it. It's not complicated, but rather than sort of making it again, I'll just paste the same thing here. So what I have is I have this one sphere, and I've given it like a mountain top to make it slightly rocky. And then this comes out as like out rock. And then I have a grid, which is one remains at the base and it's really big. So this will be the ground. And then one I have moved up, and this will be my emitter. And what I've done is I've given it like a noise for density. Okay, so you'll get like a slight bit of variation. And this will roughly be what we want. Let me just bring this in here. And so we can get started. So I'll just create a pop network, and I'll just connect all three. Yeah, and let's also change the background and make it dark. Okay, so the first thing we want is I want to limit the emission to just 60 frames. So I'm going to take constant activation and make it $FF less than 60, and also we'll get the life expectancy down to 3 seconds and a little bit of variation. Okay, so what we should get is something like that. Okay, which is, it's not moving right now, but I'll give it a little bit of force. So let's take a pop force, and we'll use this as gravity. So let's call this gravity, and I'll make it minus 9.8. Okay, so this will be our gravity. And I'll also come into the velocity, and we'll set it to initial velocity and make it around 0.1. So you'll get a little bit of variation when it falls. Now we're getting the bands happening in there. So I'll just come into my pop force. We'll turn on use vex expression, and you don't need to do anything. Just like if you click on this drop down arrow, you'll get randomized magnitude. Okay, so just randomize it. It'll give you the function itself like automatically. So if you press play, you'll get, it'll be more random. So the banding will go away. So technically what it's doing is it's randomizing it between 0.5 and 1. So it just looks a little better. Okay, now the first thing we want is we want to set up the collision. So which is going to be fairly simple. I'm going to take two different static objects, and I'm going to pick up, let's call this ground, and we'll pick up the ground. Okay, and then I'll pick up another static object, and I'll call it, we'll pick up the rock, and let's call it rock. And then we can merge these together, and we'll merge it with this. So we'll take a merge again, and this and that. Yeah, so we should get our collisions. Now what I want to do is I don't want to see the geometry, so let's just turn on display geometry, and if you press play, you'll get your collision. But the problem is nothing is colliding with the ground, okay, which is an issue. So the reason why that's happening is the default collision type is kept to volume, and the ground is just a flat plane, so it can't calculate the volume. So what you want to do is you come to the ground, you come to collision, and change the collision detection from use solver default, which is volumes, to use surface collision. And now if you press play, so you'll get your basic collisions happening, which is good. Okay, now the next thing is I just want to adjust the some of the values. So we'll come back to the physical tab. I'm going to, for the ground, I'm going to lower the bounce and lower the bounce forward as well. So which acts a little bit like friction, so it doesn't, move as much. And also for the rock, I'm going to just lower the bounce value. I'll keep the bounce forward to the same. Yeah, I think this is good. Okay, so this is fine. Let's just lower the timeline to around like 160 or something. So this is fine, like it's at a decent place at the moment. All right, so now what we want is we want to create a group for when the particles hit the rock, and we want to sort of slow it down so it looks a little straighter, so it doesn't really spread out as much. So in order to do that, we can use a pop collision detect. Okay, so what we'll do is I'm just going to give this some color. So we'll just do pop color, so it's slightly darker than this. I'll also turn off the guide. Okay, so this is fine. Now what I can do is I can take a pop collision detect, and you can pick it up at SOP level as well. So I'll just come here and I'll pick up the rock. So it will show me the rock. And what I want to do is, I don't really want to change anything. Okay, I just want to create a group out of it. So don't color the hits or anything. I'll just create a group called rock, and we'll click preserve group. Now what we can do is take another color just to visualize it. So we'll take a pop color, and the group will be rock, and let's make it like a bright blue or something. So if we press play, we should see there you go. Okay, so those are the ones that are hitting. It doesn't pick up all of them, which is fine in our case. What you can do is you can try to lower the bounce a little more and maybe lower the bounce forward, so it will stick a little more to it. See, there you go. So almost immediately you start getting a little bit of friction, and it's starting to form like those rivulets that we want, which is good. Okay, now what we want to do is we want to slow it down a little bit more. So I can take a drag, like a pop drag, and this will also affect the rock, and I can drop it in over here. And if you press play, see, it slows it down. It doesn't spread around too much. So we're almost there. Like this is the effect that we want. But the last thing that we want, which is important, is we want to generate, we want it to sort of form actual streams. So in order to do that, we need to use something called as pop interact. Okay, now let's do one thing. Let's just create a separate thing for pop interact so I can just show you what it does. So let's do one thing. Let's create a second pop network. This is just for example. Okay, and I can take this, which is my basic emitter, and I'll just pick up the ground. Or let's not pick up the ground. Like let's just take this. And what I can do is I can take a pop force, and let's drop it. So we'll do minus 9.8, and let's do one thing. Let's take a ground plane. Okay, so we can take a ground plane and then group it with this. So we'll take a merge, and we'll merge the particle system with that. And it falls and it bounces, which is good. And then do the same thing that we've done before, which is we turn on Vex expression and randomize it. So we'll get that. And also let's give it we'll just lower the lifespan a little bit. And we'll come into attributes and do set initial. Okay, so we'll get like a little bit of randomization. And then finally we'll come to the ground plane, and I want to just lower the bounce and turn off display proxy geometry. A little bit more. Yeah, so this is good. Okay, let me just lower the particle count a little bit. So what pop interact does is it sort of calculates the interaction between particles and gives it like a fake interparticle collision. Okay, so if you want to space out particles, pop interact is the way to go. Okay, so it's not really calculating interparticle collisions because that takes too long, and you can do that using like pop grain. So but pop interact is like it just generates like a fake sort of a radius around each particle, and then depending on the force value they'll sort of spread out. Okay, so the way it works is I want that to happen for the ground, okay, when they're hitting. So I'll come to the pop solver, and the pop solver also has an option to create a group out of this. So I can come to collision behavior, and you'll find that it has almost similar options to the pop collision detect, and turn on like add hit attributes, and you can generate a collide group. So we'll just call it say ground, and I'll color the hits. So let's see if it works. Yeah, there you go. So you have your particles, changing color. And what I can do is I can take a pop interact and set it to the ground group. Okay. And if you press play, you'll immediately see the difference. So you can see it starting to spread out. Okay, like if I increase this a little bit more, and if I increase the core radius, see, there you go. So what happens is it sort of like it tries to spread out the whole thing and give it like spacing. Okay, and you can also try to increase like the velocity force, so they even out a little bit. But this is essentially what it does, which is quite nice. So if you want the particles to sort of spread out and generate a space between them, see, this is without. Like if I turn it off and press play, so this is what you get, like they're not spreading out or anything. And then if you turn on pop interact and press play, then it does this. Okay, we can try like a slightly lesser value, which will be fine. Okay, like it spreads out a little bit, but it still looks nice. Like they don't look all just bunched up in one place. Now the question is, how do we use this to generate the the tiny streams that we want? So what you can do is we'll come back to our pop network again, and this is where it becomes interesting. Okay, so this is what we have, which is good. So how do we use pop interact to generate streams? And the way to do that is in the pop interact, like let's set the group to rock. The great thing is that you can actually set the position force to a negative value. So rather than pushing everything away, it will actually bring everything together. Okay, so if I take the position force and make it say -1 and press play, you'll start seeing, see, there you go. So it starts to form these nice little streams. And what you can do is, don't make it -1. -1 is a little too much. So make it about -0.5. And we can try to increase the radius. So it sort of, brings everything together a little bit more. And there you go. See, so this looks quite nice. It gives you these nice little streams. And what I can also do is I can come to the rock and kind of lower the bounce forward, so it sticks to the rock a little bit more. See, there you go. So it gives it more of a chance to form the streams. And we can turn off the guide geometry so that it looks better. Yeah, there you go. See. And so now as a final thing, I just want to color the whole thing. So what we can do is I can get rid of this color that I have. So I can just delete that. And in the initial color itself, I'll just color everything to something slightly better looking. So what I can do is, let's set this to ramp, and we will set it to, let's set it to speed. So come here and set it to speed. Okay. And then let's set the range to something slightly higher. Okay. So let's go to about 5. Okay, and then just flip it. There you go. Okay, so that looks interesting. And maybe we can like change these colors. So let's make this like a dark blue. And let's make this light blue. Okay, so that looks interesting. And the next thing we want is, I also want to give it like an alpha so it fades away. So just take an alpha and we'll say update alpha and set it to ramp and keep it to age, but like it's bright or it's more visible in the beginning and less towards the end. Or what we can do is we can do it like this. So it's like when it's born, it's invisible and then it fades in and then it fades out. Okay, so if I press play, that's what you get. See, so it gives you this very nice effect of the whole thing sticking to the rock. And then I can just come back to my particle system and we'll increase the value to around 25,000. And let's press play and there you go. And let's also do one thing. In the gravity, we'll also give it a little bit of noise so that like the particles when they fall down kind of move a little bit. Otherwise you get like this really sharp outline, which is fine, but it looks a little weird. Like let's try to increase that a little bit. Yeah, this isn't bad. See, so it sort of moves a little bit at the base. Yeah, so you get like these nice little rivulets, which is technically what we want. And the one thing you need to do is once you come out to SOP level, you will see the sphere and the grid, and we need to get rid of those. So the simplest way to do it is take a blast, and you don't know the geometry count of those. So what you can do is, like, one option is you create a group out of these, these geometries, and then once you come out, you can delete those groups. Or the simplest option is we can delete the first input, which is your core emitter, and then do delete non-selected. Like that's it. So it will just keep the points and delete the geometry. Usually the source first input covers all the particles. Okay, so like everything is part of it. Unless you do like a replication in there, then you just pick up that and the point replicate. But yeah, there you go. So that looks nice. And then let's just lower the point a little bit. Yeah. Let's try to keep it to lines and see what we get. No, let's just keep it to points. I think points is better. So yeah, so this is essentially it. So this is the first sort of mini project, and we're gonna do a fair few mini projects, but this is the first one. All right. So in the next video, we are going to take a look at. We'll continue with the collision stuff, and we'll take a look at how to create a variety of shock waves. So like a geometry or like a particle hitting something and then generating a shock wave out of it. So that's what we'll take a look at.